So we left off with some homework. Your homework from last time was to read this book, the Venting Principles Handbook, okay, or the Sizing Handbook, to at least page 40. That'll give you the pertinent information you need, and then to complete this venting rules practice test. So what we're going to do first is go over this and correct it, and make sure you guys know where the answers are found in the material that you can take into the test. So we're going to start with number one. We'll start with Kurt and Tim. Who is responsible for proper appliance venting, and where did you find that information at?
So I got who is responsible for proper appliance venting.
So responsibility for proper venting of the appliance rests with the installing agency. All right, good deal. So we'll have you, Kurt, as long as you're on, we'll have you do the next one. Number two, what'd you come up with on that one? How shall a venting system be designed and constructed?
As to develop a positive flow adequately conveying all combustion products to the outside atmosphere. On page 94.
Page 94, right there. It's also in your IFGC 503.3. Okay, so those are two resources where you can find that information. All right, Kurt, as long as you're on, we'll have you number three. What'd you get on that one?
So the draft hood equipped appliance operates with a non-positive vent pressure. Page 12 of the Sizing Handbook.
Natural draft appliances, draft hood equipped appliances operate with a non-positive vent pressure. The heat of the flue products provides the thermal lift to achieve a strong draft in the vent. Okay. Kurt, would you come up with number four, and where did you find it?
Okay, number four, I got a Category 1 fan assisted appliance operates with a non-positive vent pressure. In the same page on the Sizing Handbook.
Category 1 fan-assisted appliance are designed to operate with a non-positive vent pressure. This is an important little statement right here. I find this, a lot of people didn't understand this. The fan in a Category 1 appliance is not intended to assist the flow of flue gases up the vent. The flow of flue gases up the vent is dependent on the heat content of the flue gas. Okay. Alan, number six. What'd you get on that one?
Number six. Page 15 of the Sizing Handbook.
Okay. So in the Sizing Handbook, page 15, proper gas venting should perform the following functions. Let's see, as long as I got you on there, let's go ahead. Number seven, what'd you come up with on that one?
Venting systems shall not pass through any air duct or furnace plenum, page 95.
You can also find that in the IFGC 503.35. Okay. Number eight, what did you get on that one, Alan?
3, black iron, galvanized iron, and copper, page 96.
And you can also reference IFGC 503.10.2. Okay, both of these books you can take to the test with you. Again, I'm going to say it 10 billion times. All of the answers are in the books. You just got to know where to find them, okay? All right. Number 9. What'd you get on that one there, Alan?
Unlisted single wall vent material must maintain 6 inches of clearance, page 97.
Okay, so right there, type C, unlisted single wall. Again, I'd be highlighting all this stuff or tabbing it or whatever, just some way so that you can quickly find the information. Okay, number 10, what'd you get on that one, Alan?
No less than 1/4 inch per linear foot, page 98.
There's another reference place we can find it, the IFGC 503.10.7. Very good. What did you come up with on number 11, Jordan?
Type B or type L on page 98 of good practice.
If you had a single wall pipe running through, like, say, a crawl space, it's very cold, it's probably going to cause the hot flue gases to condense inside of it, right? So we want to do everything possible to keep the flue gases as hot as we can. Let's go ahead. So Jordan, number 12, what'd you come up with on that one?
When may a vent connector be connected to a fireplace flue if the fireplace flue opening is permanently sealed?
Okay, and where did you find that at?
On the IFGC on page 95.
Okay, in the IFGC, it's section 503.10.12. Okay, make a note of that. IFGC 503.10.12. 13, what'd you come up with on that one, Jordan?
Page 94 of good practices.
Next one, Jordan, 14, what'd you come up with on that one?
Listed vent cap installed with accordance with its listing and manufacturer's instructions, and I found that on page 99 of good practices.
All right, okay. I'll have you do 15 and then we'll pick someone else.
If you're terminating a gas venting system 7 feet away from a swamp cooler, how tall must it be to vent? No less than 3 feet above forced air inlet located within 10 feet.
Within 10 feet of a swamp cooler or any kind of other mechanical air intake, you've got to be 3 feet above it, okay? But also note this provision shall not apply to the combustion air intake of a direct vent appliance, okay? So there is an exception there. Tyson, what did you come up with on number 16?
I found it on page 100 of the good practices. Gas vent caps having an internal diameter of 12 inches or less shall be permitted to be terminated in accordance with table 10, provided that they are located at least 8 feet from a vertical wall or obstruction. All of the type B gas vents shall terminate not less than 2 feet above the highest point where they pass through the roof, and at least 2 feet higher than any portion of a building within 10 feet.
Okay, very good. And it's also in the IFGC, right? In 503. The 503 section of the IFGC is devoted to venting, okay? And they even give you a little diagram down here that kind of shows you what they're talking about, because that's a whole mouthful of words, right?
Yep.
So they even show you a picture of what they're referring to. Okay, so let's go back over here. Okay, so number 17. What did you come up with on that one?
1.25 feet.
Okay, how'd you figure that out?
I think one of the diagrams, I didn't write down the page where I found it. I should have.
So it's right here in the good practices 102, and they've got this table, and it shows your roof slope. So the question was, when terminating a 6-inch gas venting system on a roof with a 712 slope, how high above the roof must the bottom of the vent cap be? You can go right to this table, find your roof slope. So 1.25 feet, okay? That's also in the IFGC 503.6.4. All right.
The table in the sizing handbook is different though.
Is it? Are
Yeah.
you sure?
Pretty sure.
Pretty sure?
Go to page 21.
All right, let's see.
Says it should be 1 foot, not 1 1/4.
Let's see. So, roof pitch, flat to 712. This, and it's got an asterisk. This requirement covers most installations. So, whenever you find a discrepancy like that, whatever the local code is what you're going to follow. So this is what Dominion Energy says. So they are, how do they word that? The authority that has jurisdiction. Okay. So if you were going to argue this, well, this is Simpson's Duravent book. It's a great book, but here in Utah, they're going to default to Dominion Energy Good Practices book or the IFGC, which is the same as this. So bear that in mind. You will sometimes run into things like that, okay? So the authority having jurisdiction is what they're going to base it off of, okay? And when you're taking the test, this is the right answer, this book or the IFGC, okay? Teen, so what'd you get on that one?
Good practices 103. Mechanical draft termination. Appliances shall not terminate less than 4 feet horizontally nor less than 1 foot above any door, operable window, or gravity air inlet into any building. The bottom of the vent shall be 12 inches above grade.
Okay, and they even show you pictures of all different scenarios of how that might look, okay? So go ahead and tell me the next one. Define mechanical draft. What is it, and where did you find the definition?
I went to page 23 on good practices. A device installed in and made part of the vent which will provide a positive induced draft.
Okay, so let's talk about this for a minute, because guys get really confused about mechanical draft and direct vent appliances. Like, I know guys who've been in the business for a long time, and they thought that 90% furnaces fell under this definition. They don't. So a mechanical draft system would be like a power vent water heater. It still pulls its combustion air from the CAS, or the room it's in, but it has a fan in it that actually pushes the flue gases out, okay? So that would be an example of a mechanical draft system. They actually make a fan system. There's several different ones on the market that you can install into a natural draft water heater, which will allow you to now vent that natural draft water heater sideways. So instead of having to go up through the roof, and that is also a mechanical draft. So again, a device installed and made part of the vent, which will provide a positive induced draft, okay? So a lot of guys confuse this with direct vent, okay? So let's go to the next question. What are the vent termination clearances for a direct vent appliance? Where'd you find that one at, Tyson?
Page 103 on good practices. Direct vent termination. Vent terminations of direct vent appliances with input ratings less than 10,000 BTU per hour shall terminate not less than 6 inches from any opening which products of combustion could enter the building. Appliances over 10,000 BTU per hour but not exceeding 50,000 BTU per hour shall terminate not less than 9 inches from any opening. Appliances with ratings over 50,000 BTU per hour shall terminate not less than 12 inches from any opening into the building.
Okay, very good. And they even give you examples down here. A direct vent appliance, okay? That's the next question. What is a direct vent appliance? Where'd you find the information for that at?
Page 18, good practices. Direct vent appliances, appliances which are constructed and installed that all air from combustion is derived from the outside atmosphere and all flue gases are discharging to the outside atmosphere.
Okay, so that would be a 90% furnace with two pipes, an intake and an exhaust that both go directly to the outside. Or a direct vent water heater, two pipes, they both go to the outside. Now, some manufacturers, in fact, most of them, of furnaces, allow you to vent this appliance with only one pipe going outside and leaving the other pipe open in the mechanical room. If you do that, you're no longer a direct vent appliance. It now turns into a mechanical vent appliance. So if you have, and I'm sure some of you have seen it out there in the field, a 90% furnace with only one pipe on it, the manufacturer will let you do it as long as you have enough combustion air in the room. So remember from our last combustion air practice, but now it's no longer a direct vent appliance, it's a mechanical draft appliance because you don't have the other pipe going to the outside. 22, how shall a positive pressure vent system be designed?
I couldn't find that one.
Ooh, yeah, that one's a hard one. That one is in the IFGC 503.3.3. IFGC 503.3.3 number 3. Okay. And basically what it says, if you have your IFGC, go ahead and look up and follow along, but I'll just I'll read it for you here. So 503.33 23, what'd you find on that one?
Oh, let's see. When sizing a venting system for a single draft hood equipped appliance, the area, vent, and the vent connector shall not be greater than 7 times the draft hood outlet area.
Right there. No greater than 7 times the draft hood outlet area. When they're talking about the area, they're talking about the square inches of the opening. You may have heard that some of the HVAC guys sometimes refer to the 7 times rule. This is all it means, is that when you're sizing an individual gas vent for a single draft hood equipped appliance, so one appliance with a draft hood, the area of the connector, so the pipe that connects to the appliance, and the gas vent, so the whole venting system, shall not be less than the appliance draft hood outlet. So let's say the outlet was 4 inches, so we couldn't hook 3 inches to 4 inches, nor can it be greater than 7 times the draft hood outlet area. And when they say area, they're talking about the square inches. So the next question, what is the area in square inches of a 7-inch vent? Where'd you find that at?
On page 108, and it's 38.48.
Okay, so there is a math formula to figure it out. It's called pi r square. A 7-inch round vent has an area of 38.48 square inches. So again, that rule they were talking about, the 7 times rule, if I have a water heater with a 4-inch connector on top of it, my pipe can be no bigger than 7 times this number. Does that make sense? Okay, 25. What'd you come up with on that one? The question was, when designing a gas venting system and you need to install 4 90-degree elbows, you must reduce the venting system capacity by how much? 10% reduction for additional elbows greater than 45 degrees up to 90 degrees. So when you start adding elbows in, when we get into the sizing tables, this will start to make more sense. Elbows are restrictions to flow in there. So when you start adding elbows, you got to start taking reductions in capacity. Turner, what'd you come up with on 26 about corrugated chimney liners?
The question is, when installing it, how much do you reduce it by? So right there on page 110, 20% reduction for corrugated chimney liner.
If you're using a corrugated chimney liner, you got to take a 20% reduction in what the tables tell you it is capable of doing. The reason for that is because of the corrugations. It's not a smooth pipe, it's all corrugated, and so that causes restrictions. And then of course, if you start putting bends and offsets, number 27, Turner, what'd you come up with on that one? I got this all the time when I was out in the field in the business. So these big fancy homes people are building. So here's the front of their house, and they don't want this ugly flue sticking out of the front of their house. So they want to offset the flue to the back. Well, there's rules about doing that. And the rule is the common vent offset shall not exceed 1.5 feet for each inch of common vent diameter. Okay. So in this case, the question was, you had a 6-inch common vent. So the common vent is your main flue that goes up through the house and out the roof. And the math looks like this: 6-inch vent times 1.5, 9 feet. So let's say I had a 7-inch vent and I wanted to offset it back. I would simply take my 7-inch vent times 1.5. 1.5. My 7-inch vent, I could offset back 10 feet. What if I had a 5-inch vent or main flue? Simply take the size of the flue times 1.5. Now my 5-inch vent, I can only go 7.5 feet in my offset. Okay, so that's what that's talking about, and that's what the math looks like. Okay, and they give you a picture, show you right there what they're talking about. So again, all the answers are in the book if you just know where to find them and how to read them and do a little bit of basic math. You'll find this exact same thing in the IFGC right there, 504 3.5. All right, we have one more left, number 28. So go ahead and finish this on the last one, Turner, and then we'll start learning how to size vents and use the tables.
So vent connectors shall not be increased in size by more than 2 sizes greater than the listed appliance vent diameter on page 113 of good practices.
Vent connectors shall not be increased in size more than 2 sizes greater than the listed appliance categorized vent diameter, flue collar diameter, or draft hood outlet diameter. So it's simply telling you, if again, let's use a water heater as an example. I have a water heater and it has a 4-inch draft hood on it, and that's where my flue connects to it, right? Okay, this is telling you my vent connector that connects to it cannot be more than 2 sizes bigger. So if I've got a 4-inch flue collar at the water heater, I can't put a 7-inch pipe on it, right? I can't go more than 2 sizes bigger than whatever the outlet is. That's simply all that's telling you. So there's where we found all the answers to that. And we're going to start working with these vent sizing diagrams I sent you. And this is exactly the kind of stuff you're going to see on exam day. Okay, they're going to show you a picture just like I've got here. You've got 16 of them. I'm going to help you do a few of them, and then I'll turn you guys loose on the rest, and that's going to be your homework. The first thing that you need to know is that there are several different tables. So right now I'm in the vent sizing handbook, okay? And here's table 1. And table 1 is type B double wall vents. So this is my main flue going through the roof, and I'm using type B double wall connectors. So basically this is the whole flue is type B or double wall pipe. Okay, that's when they say type B, they're talking about double wall pipe. And this is serving a single category 1 appliance. If I go over to the good practices book, that exact same table is also in the good practices book. And this exact same table is also in the IFGC. The thing is, you've got to know which table you're working in because there are several of them. Here's another table. Type B double wall vents. Okay. Oh, we're still in the single category 1 appliance, sorry. Now it changes. Type B double wall vents with single wall metal connectors. So now we've got our main flue going up through the house is a double wall, okay? And that should always be a double wall pipe. You can never run a single wall as your main vent, but we're going to connect to it with single wall pipe. So there's a table for that. And again, we're serving a single category 1 appliance. So 1 appliance. Now we're going to go down to some different tables. Table 3, double wall vent, double wall connectors, serving 2 or more category 1 appliances. So now we've got another table, table 3. We have 2 appliances in there, category 1. And again, double wall vents, double wall connectors. Table 4, all these different tables. We got our double wall vent, will always be a double wall vent, so a main vent will always be double wall, but now we're using single wall connectors, and again, serving 2 or more category 1 appliances. This is where I find guys make mistakes. They get in the wrong table. So make sure you know what table you need to be in, and that's these vent practices we're going to do. That's what's going to help you get through this. That's why I have 16 of them I sent to you. Because this is a little complicated and it can be a little daunting if you've never done it before. But if you can just read the instructions and make sure you're in the right table, it's really Not that hard if you practice and do it. So we're going to start with this first one here. And on test day, these are the types of diagrams you're going to see. So they're going to show you a little picture of a house. They've got the total vent height as 10 feet. And they're asking you, what appliance connector size and type can I use? And what should my common vent size be for this appliance? And right here it says NAT. That means it's a natural draft appliance. On test day, when you see NAT, that means it's a natural draft appliance. The other thing you're going to see is fan, because in the tables, notice we have fan and NAT. So we got to make sure when we see the diagram that we understand what we're looking at. So this is a natural draft furnace or whatever appliance. It's 140,000 BTUs. My lateral run, so from here to here, is 5 feet. And my total vent height is 10 feet. So I'm going to go over to the sizing tables. And the first thing I'm going to do is, let's see if we can do this with double wall. It should always work with double wall. We could spend less money if we did it with single wall connectors, because double wall connectors are expensive. But let's start here and see what we need with double wall. And then let's go and see if we could save a little bit of money and change this connector to single wall. So what I do is I start with my height. So what was my height? 10 feet, right? So I come down the chart. I have a single category 1 appliance. I start with my height. I come down the chart and I find my 10-foot height. Now we have a lateral run of 5 feet. So I'm going to go back over to my book. Notice over here, lateral. And it gives me some numbers here to work with. Oh, look, 5 feet is even right in there. That makes it easy. So I've got 10 feet with a lateral of 5 feet. Now I've got to go back. And again, we're going to look at our thing here. I have a natural draft appliance, and it's 140,000 BTUs. Because I have 2 choices here to pick from, fan or NAT. So we have one natural draft appliance, it's 140,000 BTUs, and they're asking us appliance connector size and type. So let's figure that one out first. So if I was going to use a type B double wall connector with a type B double wall vent, I'm going to come along here. I'm on my 10-foot height, my 5-foot lateral with a natural draft appliance. It's 140,000 BTUs, and I've got to read across until I can find one that will handle that many BTUs. So let me get my little arrow here going. So if I come across to a 3-inch natural, that will only handle 40,000 BTUs. That's not big enough, right? So let's go look at a 4-inch. That'll only handle 77,000 BTUs, okay? Let's go look at a 5-inch. Again, in the natural column, that'll only handle 124,000 BTUs. Aha! 6-inch will handle up to 188,000 BTUs. So I could do a 6-inch. So because it's a single appliance, this would be a 6-inch connector of double wall with a 6-inch main vent going out. Well, what if this was just a straight shot down? One portion, like the first section of that, is considered the connector. And if it was just a straight shot down, that would mean you'd be over here in 0. You have no lateral run, so you would just go to the 0. In a perfect world, that's what we want. We want the flue to be completely straight with no elbows or offsets or anything whatsoever in it. But we don't live in a perfect world, right? Most every flue we see has got some kind of offset in it. Back over to the table. We could do this one in a 6-inch, so we would use a 6-inch connector. of double wall and a 6-inch main vent. But let's find out if we could use a single wall connector, because single wall pipe is a lot less money than double wall. We know we can do it in double wall in 6-inch, but let's go down and see. Okay, so now I'm down to table 2, type B double wall vent, and your main vent will always be double wall. You can never run a single wall main vent, but you can run single wall connectors. And guys do that because it saves money. So we do the same thing we did before. I come over here to my height. I run down 10 feet. My lateral is 5 feet. So I come over to my lateral. I run down to 5 feet. I have 140,000 BTUs. Okay, so I got to make sure that I can get that many BTUs through it. And remember, it's a natural draft appliance, so I've got 2 choices up here. I've got a fan column, and I've got the NAT column, or natural draft. So I'm going to come across with my arrow, and I'm going to find out. Okay. So 3-inch won't work, 4-inch won't work, 5-inch won't work. So I could do that flue with a 6-inch single wall connector, and the main vent or the main stack or the main flue, whatever terminology you like to use, will always be double wall. So in this case, I could save money by switching to single wall. The charts allow for it. And that's how you figure it out. So the answer to this first one would be, it could be either B vent or single wall, the common 6-inch, and the common vent size 6-inch. Okay. You may see questions that say, what is the minimum type of material you could use as the connector? So in this case, the minimum type connector, is single wall. That's what they say when they refer to minimum type connector. Single wall, less expensive. Okay. So if you wanted to use single wall to connect this furnace to the main stack, you can, as long as it's 6-inch single wall.
I got a question or two, Wade. When it says connectors, we're talking about elbows, is that right?
Okay, so connectors, let's see if I can help explain this a little better. So you'll always have your main stack, and it's always going to be double wall. So that's the stuff that goes up through the house and then ends somewhere in the mechanical room. And then you're going to have connectors. So it might be a piece of pipe, 45 or an elbow, a piece of pipe. In this case, it's a piece of pipe, 45, a piece of pipe, 45, and another pipe. And then the rest is your main stack. So your connector might be a 12-inch piece of pipe, and then the rest is your main stack. And in a perfect world, that's how we'd like to design them. And the venting tables, if you're in that situation, that just means you have no lateral run, 0 lateral run. So if I had a pipe that came straight down on top of the furnace, I would use the 0 lateral run. Okay, so I would just simply, what I want you to note here is what happened when I moved to a 0 lateral run. Look how many more BTUs I could handle.
I'm still not understanding the connector stuff.
Okay.
Can I ask a couple more questions?
Yes, ask away. This book that I had you read has got some great examples. So for instance, let's start with this one here. So if I'm looking at this one, my main stack here is the main double wall pipe that goes up through the floor. So this would be my floor of the house, and up through the house and out the roof. And somewhere in the mechanical room, that main pipe is going to terminate. Okay. From that termination point, or that joint, which in this case is right here, everything from there back to the furnace is basically considered the connector. Okay. So let's see if we got some more pictures here to help you understand that a little bit. Okay, so here's another great example. So here I've got a floor, okay? I've got my main stack going up through the house, and now I've got a furnace over here. So everything from this T right here, okay, so my main stack comes down and we've got a T in it because there's two appliances now. And it'll probably help clarify it once we get into two appliances. But my main stack comes down and there's a T. So now everything from here to this appliance is considered connector, and everything from here to this appliance is considered connector. Here's a great example of what I talked about where it just comes straight down. So again, my main stack is coming through the house, through the floor or whatever, or the ceiling or wherever it comes through, and it terminates there with a joint. And so they've got a connector. That connector will go on there, and this piece of pipe and another connector. So everything, this, and this are all considered connected. Does that help clarify?
Is the connector, yeah, I'm getting a much better picture. Is the connector ever allowed to be buried within the building cavity, or does it always have to be out and accessible?
Connector has to be in the same room as the equipment. Okay.
Okay, that helps. Perfect. Thanks, man.
Somewhere in there, if you read the book, it talks about that, how the connector will always be in the same room as the appliance, basically. Okay?
Gotcha. Sorry, guys, I didn't read the book, obviously.
Don't worry about it.
I didn't
Wasting your
either. I
time.
got another question.
Yeah, go ahead.
So on that second example you gave, that T that connects the water heater to the furnace, that T, is that considered a connector as well, or is it just that connector? Like, because you said that everything from the water heater to that T is the connector, and then everything from the furnace to that T is the connector. Is that T a connector as well, or is it just everything past that point?
The T would be part of the main stack because the T. So let's assume this is 6-inch. So this T has got to be 6-inch to hook onto the main stack, and then off of the T, depending on what the tables tell you, this may be 3 inches. So from the T down to this point, this is all connector. And then also from the T, this might be 4 inches or 5 inches, okay, depending on the tables. So from that point down is going to be the connectors. So typically when in new construction, when we run a flue, we run our main stack first, okay? And that main stack could go straight, it could offset. And so I'll use an example just like this as a basement. So let's assume this is a basement. I would run my main stack up and out the roof and terminate in the basement, in the CAS or mechanical room with this T. Would have sized my equipment up front or my flue up front so that I know which T I need to buy from the supply house. So in this case, let's just assume a 6-inch main stack with a 3-inch water heater connector and a 4-inch furnace connector. So my T would be a 6 by 3 by 4, and it's part of the main stack. Does that help clarify? Okay. Over here, let's see. Great pictures right here, okay? So here we have two appliances. I have my main stack, and at this point right here, I've got a connector, and this is all considered a connector, okay? So my common vent starts at this T and is everything that goes out to the outside of the house, okay? My connectors come from the T to each appliance. Now, let's assume that this appliance isn't here. I only have one appliance. This wouldn't be a T. It'd just be the pipe ending right there, okay? And then my connector is everything that gets me from the main stack to the appliance, and it has to be in the same room as the appliance. Okay. Does that help?
I have a question, Wade.
Yep, shoot.
Those T's and those connectors that come off of the main appliance, do those all got to be B vent?
That's what we use the charts for, okay? So like the one we just did, we were trying to find out what can our connector be, okay? Okay, so again, we were trying to find out on that first practice one, what appliance connector size and type can we use, and what common vent size, okay? So we wanted to find out. We found out we could do it. It can all be double wall, okay? So the whole thing could be double wall, but I want to save a little bit of money on the job because double wall is expensive. So maybe I'm going to go look and see if I can use single wall as my connector, okay? I already know I can do it in double wall, but shit, double wall is a lot of money. So maybe if I can get away with single wall, I can save a few bucks and put a few more bucks in my pocket. So we came down to the single wall connectors, and we did, I'll go through it again just so you can see. We start with our height. Again, we're serving a single category 1 appliance. My height, 10 feet, okay? My lateral, 5 feet. It was a natural draft appliance, so I'm always going to be looking in the natural draft column. And I need to get 140,000 BTUs through that pipe. So I come across, well, 3-inch single wall, with a 3-inch single wall connector, I can only get 39,000 BTUs up that pipe. If I have 4-inch, I can only get 76,000 BTUs. If I have 5-inch, I can only get 122,000 BTUs. But if I have 6-inch, yeah, it'll work with a single wall connector. So back to the picture, my main stack will always be double wall, but now I could save a few bucks from this point down. I could do it in single wall as long as it's all 6-inch pipe. Both tables showed me, so the table for single wall and the table for double wall both said for that single appliance to get the 140,000 BTUs up and out the pipe, it's got to be 6-inch. Double wall work, it can all be double wall. Or if I want to save some money, and that's really what this is about. That's why contractors do this. Single wall pipe is a hell of a lot less money than double wall. So if I've got a lot of connector and I can change it to single wall, I probably will, because it'll save me money. So I could do this one either way, with double wall or with single wall, as long as the entire thing is 6 inches.
Hey Wade, I got one other question. So when we're looking at the total vent height, does that go to the tippy top of the cap, or does it just go to the top of the pipe and then you put the cap on?
Total vent height is that. You just draw a straight line up, okay? And in that book, that vent sizing handbook, and even in the good practices book, it talks about it. So for example, this one here, my total vent height on this one would be from this appliance here, okay? This is my lowest appliance, or see how it's shorter than that appliance there? So my total vent height would be that.
Wait, on the diagrams you gave us, you asked us 2 questions at the bottom, common vent size and then the appliance connector size and type.
And they're both, so hold on, let me get rid of this.
Am I supposed to be writing down? I know we figured out 6 inches, the main stack we want, common vent size.
Yep. So,
And we figured out we can use single wall connector size type, but the
okay.
size, they don't have to be 6 inches, right?
Yes, it has to be 6 inches. Okay, so remember, we go back into the table. We're serving a single category 1 appliance, and I want to try to see if I can do single wall metal connectors. Okay, and I discovered, yes, I can, but they got to be 6 inch still. So the whole thing has got to be 6 inch. But this stuff here, instead of spending what would be close to 150 bucks on double wall, I can spend about 10 bucks on single wall. But it's still got to be 6 inch. Everything's got to be 6 inch. So we could use B-vent or single wall as my connector type, and it has to be 6 inch. Okay, and my common vent, 6 inch. Okay, so that's the answer to that one. I want you to get out vent practice number 3, because now look what happened. It says fan, right? It's no longer a natural draft. It's a fan assisted appliance or a category 1 appliance. Okay, this is where stuff starts to get confusing and guys get confused, and but hopefully I'll be able to help you get through it. Okay, so we're still serving a category 1 appliance. Okay, but it's just a fan assisted, so it's your basic 80% furnace. And remember, in our test we took, or the little practice thing we went over, a category 1 fan assisted furnace operates under a non-positive pressure, so it's just like a natural draft appliance. The fan on a category 1 appliance does not push the flue gases out. This flue has to be designed just like a natural draft flue, because the flue gases, once it gets right about here to this point of the flue, it's depending on natural draft or the buoyancy of the hot gases to get out. Okay, that's a big confusion I've seen over the years. Guys think that those fans in 80% furnaces force the flue gases out. They absolutely don't. Okay, only on 90% furnaces do the inducer fans, or what they're called, do they force the flue gases out. Okay, so everyone have vent practice number 3 in front of their face. So again, we're going to go to the sizing handbook, working with a single category 1 appliance. Okay, so we're going to be in table 1. I've got a total height, but now I'm dealing with a fan assisted appliance, 60,000 BTUs and a 15-foot lateral. 15, that's a big long lateral run. That's going to create a lot of resistance in it, right? And we need to be able to move 60,000 BTUs through that. So I'm going to come back over here. Now that I've got my height and my lateral, I'm going to find out, and look, we're going to have to be using the fan column now, and it's got a min max. We'll talk about that. So my maximum BTUs is 60,000. So let's see, will 3 inches work? Will 3 inches max give me 60,000? It won't, right? It only gives me 53,000. I can only move 53,000 BTUs through it. So I can't do that flue in 3 inch, but if I come across to the next table. Oops. My fan, the maximum amount of BTUs I can put through it is 112. And the minimum amount, now this is where it gets a little complicated and convoluted. I have to have at least a minimum of 48,000 BTUs of heat energy to make that flue work. Flues work because of hot gases. Gases rise up. And on fan-assisted appliances, there is a spread. There is a minimum amount, so I have to have at least 48,000 BTUs of heat energy, and I can have no more than 112 BTUs of heat energy. If I go less than 48,000 BTUs, there's not enough heat energy in there for that flue to work. The flue gases will just go in there and condense. They won't go out. They'll just turn to water, and the flue won't work. The whole premise of how flues work and why we use double wall is to keep them hot. Remember on CAS testing, you always start with a cold flue. The reason for that is because cold flues have a hard time venting. You got to keep them hot. And on fan-assisted appliances, it's critical. They give you a spread, so then you've got to be between those two numbers. So this is telling us, because we have a fan-assisted appliance, we now have to have enough heat in there to keep it working. If we don't have enough heat energy in there, it won't work. And so now the book gives us, with a fan-assisted Category 1 appliance, I've got to have a minimum amount of heat energy. I've got to have at least 48,000 BTUs, but I can have no more than 112,000 BTUs. Does my 60,000 BTUs fall between those two numbers? It does, right? Okay. So we could do this flue with type B double wall connectors. Remember, our main stack will always be double wall, and it can be 4-inch because I've got my minimum amount of heat and I'm not exceeding my maximum amount of heat energy. So I can keep it hot enough to work, but I'm not going over what the physical size of the pipe will allow me to push through it. Does that make sense? What I want to know now is, could I do this same thing, but change this connector to single wall? Because I'll save money if I can do that. So let's go back over to our event book. We just figured out we could do it with type B double wall. It'll all work in double wall, and it would all be 4-inch. But I want to try to save money and use single wall connector. I want to go down and find the table for a double wall vent, but I want to try to save some money and use single wall metal connectors. So let's see if we can do it with some single wall connectors. So I'm going to come over to my height. I'm going to run down to 15. And again, I'm going to come over to my lateral. They gave me a 15-foot lateral on this guy. That's a lot of sideways run. Now, let's find out if we can do this with a single wall connector. If we use a single wall connector, so last time we were able to do it with 4-inch when everything was double wall. Oh, wait a minute. If I switch my connector to single wall, I can't do it in 4-inch anymore, can I? Look what it says, NR, not recommended, not recommended. Huh, well, if I want to use a single wall connector, I've got to, wow. Well, remember that min-max thing we talked about? I've got to have a minimum of 158,000 BTUs and no more than 186,000 BTUs. Do I have that out of that furnace? I don't. Well, I don't think that I can use single wall connectors on this. I think that the whole flue is going to have to be a B vent flue. Because remember, let me go back at the other one here. When I did everything in B vent, so B vent connectors and your main flue will always be B vent or double wall. When I did it with double wall connectors, aha, I could do 4-inch pipe. My entire flue system could be 4 inches because I fell within the min-max range. I have 60,000 BTUs, so I have more than enough heat for the flue to operate properly, but I'm not exceeding its maximum capacity. But I wanted to save money and try to do it with single wall connectors. So I wanted to change from here to single wall. So I go over to the book. I know I can do it all with double wall, but can I do it with single wall? Nope, I can't. 4-inch won't work, okay? Because I'm on the fan, min-max, says right there, not recommended, not recommended. That means you can't do it. That won't work. Okay, well, what if I increase it to 5-inch? Nope, I don't have enough heat in there because of that single wall pipe that I tried to add to it. So the only choice I have on this one is back up here. The whole thing has got to be 4-inch B vent. So the answer to this is, let me get the typewriter, only 4-inch B vent and 4-inch. And of course your common vent always B vent.
Question. So when you're doing just a single appliance, whatever you figure out is the minimum for the connector, is that also what the main your main flue has to be as well? Like the entire,
Yes.
so like if the minimum is 4-inch, then that whole thing, the whole vent system has to be 4-inch. You can't
Correct.
like go 4-inch just to the connector and then what from the connector up be 5-inch. It all has to be 4-inch.
Yep, it's all got to be 4-inch, okay? Because you've got to have enough heat energy to heat it up. Let's say I wanted to try to go over to 5-inch or something, and again with a single appliance, okay, you're basically you have one pipe essentially, okay, and this is how you size them, okay. So if you were going to try to move that up to a 5-inch, the whole thing, well, I don't meet my minimum requirement of heat. I need 61,000 BTUs of heat energy at a minimum to keep a 5-inch diameter pipe hot enough. So that won't work, okay? So I got to come back here, and the whole thing has got to be 4-inch. We'll get into different pipe sizing and stuff when we, like you said, you can run into situations where you'll have a 6-inch main stack and some other size coming out of it. But first we got to start with the bare basics. And when you're sizing a single appliance, this is how you do it. So yes, the answer to your question is that whole flue would be a 4-inch, okay? The main stack would be 4-inch and the connector would be 4-inch. And in this case, we found out we could not change the connector. So what we run from the appliance to the main stack, it can't be single wall because the charts showed us when we tried to go down to do single wall, because we wanted to save money. At the end of the day, that's all it's about, is trying to save some money because B-vent's expensive. We found we couldn't do it in 4-inch. Right there tells us we can't do it. And when we try to go up to 5-inch with that single wall pipe in there, because I have such a long lateral run of single wall pipe, 15 feet of single wall pipe running lateral, I can't keep the thing hot enough to work unless there's a minimum of 158,000 BTUs of heat energy in there. Well, I've only got a 60,000 BTU furnace. So there's no way I can do this furnace using single wall metal connectors. Everything on that entire system has got to be double wall so that I can keep the flue hot enough for it to work. That's what it's all about. Remember the question about flue pipe running through an unconditioned space. It's got to be double wall because the double wall is insulated, and we got to keep those flue gases hot. The minute we start cooling the flue gases down, the flue stops working. And what happens to hot, moist air when it cools down? What does it turn into?
Condensation.
Condensation. And do we want condensation inside of our metal flues? Absolutely not. So on fan-assisted appliances, it is critical that you fall within the min-max. We've got to keep it hot enough. If we don't keep it hot enough, it won't frickin' work. We'll condense. Everything will start condensing in there, okay? So the only way this one will work is I've got to do everything in double wall. If I try to switch my connector over to single wall to save a few bucks, I discovered it won't work. The gamma charts is telling me you can't even do it in 4-inch, don't even try. And if I want to go to 5-inch, because I've got so much single wall in there, 15-foot lateral run, that's a long lateral run. All that single wall pipe, because there's so much of it, I've got to have a minimum of 158,000 BTUs of heat energy to keep it hot enough for it to move the flue gases. And I don't have that. I've only got 60,000. So single wall connector is not even an option on this one. I've got to do everything in double wall, okay? So again, the answer to this is appliance connector size and type, only 4-inch B vent, and common vent size on this one, again, single appliance, it's just the same size all the way up through, okay? 4-inch, and this common pipe or common vent or main stack will always be double wall, always has to be double wall. Again, in these books, if you read them, all the stuff that I'm saying is in there. It tells you that. You can never run this main stack in single wall pipe. It's always got to be double wall, okay? So again, you might see questions that say, what is the minimum type of connector you could use on this? Well, the minimum type is B vent. I can't use single wall on this. We found in the tables that if we add single wall under these conditions, 15 feet of height and a 15-foot lateral, so that means from here 15 feet over and then up, that's a hell of a lot of lateral run, right? And if that's all in single wall pipe, I gotta have a lot of heat energy to heat it up, and it won't work. The gamma charts tell us that. We can only do it in 4-inch B vent. This is vent practice number 6, so please get vent practice number 6 in front of your face. Now we got a total vent height of 22 feet. We've got a natural draft appliance, and we have a 7-inch lateral run, okay? Well, this is where it starts getting a little tricky. Because let's go over to our charts. So again, I've got a single appliance. I'm going to go start with double wall connectors, okay? And my height, there isn't 22 feet. I've got a choice of 20 feet or 30 feet. 20 feet or 30 feet. There's no 22 feet. There's no 25 feet. There's no 26 feet. There's no 27 feet. So what the heck do I do now? My height is not listed on the chart. What do you guys think I should do? Should I go higher or lower? I see a bunch of people saying going higher.
Go higher.
Go higher. Go higher. Go higher.
How many of you read the book?
Wouldn't it be you go to whatever's the closest? Like if it's you're at 22, then you'd go down to 20, and because you're 8 away from 30.
Always go
you're only 2
lower.
away. 30.
Always go lower. If your number is not listed on the chart, go lower, because look at this.
Oh,
Okay, same conditions. 20-foot height, and let's say we've got, let's see on this one, we're for example purposes, at 20 feet with a 5-foot lateral, 48,000 BTUs with a natural. But if I increase the height of the flue, notice the taller the flue, the more BTUs it can handle. Taller flues vent better until you start reaching a certain point. If I have a 22-foot total height, it's not listed on the chart, I go down to 20 because I know if a 20-foot will work, a 22-foot will certainly work because it's taller. And you notice if you just look down the chart, okay, we're over here on the natural. The taller the flue, the more BTUs it can handle. So if I have 22 feet, I'm going to go down to 20 because I know if it will work at 20, it will definitely work at 22. So always go down. Okay, so 22 is not listed, so I'm going to go down because the taller the flue, the better it will work. I have a 7-foot lateral run. 7-foot lateral. So from here to here is 7 feet. Well, crap. In my lateral run, I don't have 7 feet to pick from, right? I've got 0, 2, 5, 10, 15, and 20. So where should I go? If I got 7 feet, should I go up to 10 or should I go down to 5? A 5-foot lateral will do 48,000 BTUs. A 10-foot lateral will do 44,000 BTUs. So if I'm in between them, if I go 10 foot, it'll do 44,000. I know if I'm lower than that, I can get more. So a 5-foot lateral is capable of more BTUs than a 10-foot lateral. We're dealing with a natural draft appliance. So in this instance, 20 foot with a 5-foot lateral will do 48. 30 foot with a 5-foot lateral will do 54. Okay, so on our height, we want to go down. But on our lateral, if I fall in between the numbers, I want to go up. Okay, because if it'll work at 10 feet, which will do 44,000 BTUs, I certainly know that it'll work at 7 feet because the shorter the lateral, see how 5 foot will do more, the shorter lateral will handle more capacity. So on my main height, if you fall between a number, go down. On your lateral, if you fall between a number, go up. Because notice in the natural column, the shorter the lateral run, the more capacity. So again, the higher the taller the main stack, the better it vents. And if you just spend time looking at the charts, you'll see it. As you go higher with any given lateral, you have more capacity. But then when you start adding longer laterals, you start reducing capacity. Height, always go down. Lateral, always go up. We're working with a natural draft appliance again, so we're on 6. and I need 35,000 BTUs. I've got to be able to get 35,000 BTUs of heat energy up that gut. So I come back over here, and again, I'm working with a natural draft appliance, so I want to make sure I'm in the natural draft column. I'm using everything as double wall with a single appliance. Okay. I was at 22 feet, so I came back down to 20 on my height. My lateral was 7, so I go up to 10, because I know if it'll work at 10, it will work at 7. Now I got to come across and find what will handle 35,000 BTUs. Well, sure enough, that'll handle up to 44,000 BTUs, so that'll handle my 35,000 BTUs. So I could do that whole flue in 3-inch as long as the entire thing is double wall. So the whole flue right there, it works if everything is double wall. Now, let's go take a look and see if we could do it in single wall, if we could change this guy right here to single wall, because I want to save some money. Okay, so I go back over to my gamma tables, and we go down and we find the table with single wall connectors. All right, so here is the type B double wall vent. So our main stack will always be double wall. And we want to see if we can try to use single wall connectors in order to save money. Again, we're serving a single appliance. So I go to my height column. We're going to run down the height column. I don't have 22, so I go down to 20, because if I know a 20-foot height will work, then certainly a 22-foot height will work. The taller the flue, the better it will vent. Okay. My lateral on this one was 7 feet. I don't have 7 feet in my chart. So I go up on my lateral, because I know if a 10-foot lateral will work, well, a smaller or shorter lateral will definitely work. Because look at the difference here between 10 feet and 5 feet. 10 feet will only do 41,000 BTUs. 5 feet will do 47,000 BTUs. Okay? So I know if a 10-foot lateral will work, a 7-foot lateral will certainly work. So I go down on height, up on lateral. All right, now let's see if we can find if this will work with single wall. So we need to be able to move 35,000 BTUs. If we use 3-inch single wall at a 10-foot lateral, that'll move 41,000 BTUs, right? So we could change that connector from double wall to single wall and do it in 3-inch. As you spend time looking at the charts, you'll see the shorter the lateral, the more capacity I have. So if I fall in between on laterals, go up, because I know if a 10-foot will work, a 7-foot's going to work. So appliance connector size and type. I could do it in B vent, whoops, or single wall, 3-inch. Okay, and my common vent size could be 3-inch. It's super, super uncommon, guys. I'll just let you know right now in the world of HVAC to ever run a 3-inch main stack. You rarely see it. Usually what you'll see is a 4-inch. So we could go over and look at it if we were going to do it in 4-inch. In fact, some supply houses don't even carry 3-inch double wall pipe anymore because it's just so uncommon. So we could go over here and run and go, oh, well, I only have availability of 4-inch. Well, yeah, it'll still work. It'll handle 86,000 BTUs. I only need to get 35,000 BTUs up it. And it's a natural draft appliance. So it could be 4-inch. That would work, even with single wall, because we're still in the single wall chart. Because I know some of the HVAC guys are going, no one ever runs 3-inch double wall. You're right, it seldom happens, but the charts tell us if we wanted to, we could do that flue, B vent or single wall for the connectors. So that would be from here to here. And we could do the whole thing in 3-inch. This vent practice number 7. So if everybody will get vent practice number 7 in front of them. We'll do this one, and then I'll do number 10 with you, and then all the others you guys are going to have to do as your homework on your own. And by the time you're done, you should all be really good at sizing vents, okay? So vent practice number 7. And look at this thing. We got all these crazy elbows in it, okay? So when you see a diagram like this with all the crazy elbows in it, you need to go back and remember this. When more than 2 90-degree elbows are required in the venting system, the maximum capacity listed in the venting table should be reduced by 10% for each additional 90-degree elbow or equivalent. Please note that 90-degree elbows are only allowed in the same space as the appliance and are not permitted above the ceiling. Your main vent, your main common stack, can never have a 90-degree elbow in it. 90s are only allowed in the connectors, okay? So this is important to remember because you're going to see diagrams that look like this. We're going to deal with this one right here. Diagram number 7, and we've got a whole crap load of elbows in it. So when you see on test day this diagram or something similar to it, remember that rule. For every elbow over 2, we have to take a 10% reduction. So in this particular one, in my connectors, I have 1, 2, 3, 4 elbows. The charts assume that I'm going to have 2. Any more than 2, I've got to take a 10% reduction for each elbow. So let's go ahead and work through this one. I've got a total vent height of 20 feet. I've got a fan assisted appliance, 60,000 BTUs and a 5-foot lateral. So I'm going to go over to my sizing chart and I'm going to start and see, can I do this in double wall? Okay, and again, we're serving a single category 1 appliance. Okay, we have a 20-foot vent height. So I'm going to start and see if I can do the whole thing in double wall, what size I'm going to be. So I've already come down my height line to 20 feet. Okay, and my lateral in this case was 5 feet. Okay, so we're going to go back up to 5 feet. And I have a fan assisted appliance that's 60,000 BTUs. So now I've got to be working off of this fan column, and I've got to fall in between the min max. But I've got 2 extra elbows in there. So I'm going to have to take a 20% reduction off of whatever I find. So I'm going to go ahead and start and see. Oops. So we've got a fan assisted appliance, 60,000 BTUs. This one gives me a minimum of 21. So yeah, I've got enough heat, and a max of 71. I could do this in 3-inch. Oh, but wait a minute. I've got to take out 10% for each extra elbow, right? So I've got to reduce the capacity of this by 20% because I've got 2 elbows, correct? So let's see what that looks like. So my maximum BTUs there is 71,000. I've got to reduce it by 20% because I have 2 extra elbows in. So the math would look like this, times 0.80. Now it will only do 56,800 BTUs after I take the reduction. I can't do it in 3" anymore, right? Because of those extra elbows, I can only get 56,800 BTUs up that flue. So 3" won't work anymore because I put these extra elbows in there, right? And elbows create restrictions, and the sizing book gave us the information. For every extra elbow over 2, we got to take a 10% reduction. Okay, well now I know that 3" won't work. So let's try moving up the chart. Again, we're working with a fan assisted appliance. So I stay in the fan part here, and I got to fall in the min max. So my minimum now, when I move up to the next one, is, let me get that arrow down here out of the way. I got to have a minimum of 29,000 BTUs, which I have, right? I've got 60,000 BTUs. And I can have no more, or a max of 143, but I got to remember, I got to calculate that reduction. So if I take 143,000 times 0.80, and that's basically just 100 minus the 20%, well, that'll still do 114,400 BTUs. So does my 60,000 fall in between 29 and 114.4? Okay, it does. So I could do this entire flue in 4" double wall. So my main vent, so this guy here would be 4", and all this here could be 4". Okay. If it wasn't for the reduction I had to take, I could have done it in 3", but because of the extra elbows, when I took the reduction here, it didn't give me enough. So I had to move up to the next size. So now we know we can do the whole thing in 4" B vent. Connectors would all have to be B vent. But again, I want to try to save money. So I want to see if I can do it in single wall. So let's go down to the single wall chart and see if we can get away with using single wall metal connectors. So I want to try to do all this stuff here in single wall, because double wall elbows are about 20 bucks a piece. They're real expensive, and double wall pipe is expensive. If I can change this to single wall, I can save some money. So let's see if we can do it in single wall. So again, I've come down to my 20-foot total height. Now we've got a lateral of 5, so we're going to move this guy back up here to our 5-foot lateral. We're dealing with a fan-assisted appliance, and it's 60,000 BTUs. Okay, so I'm on my fan. I have my min-max. Okay. So does my 60,000 fall between 50 and 68? It does, right? But guess what? Because of those extra elbows, I've got to reduce my maximum capacity. I have 2 elbows, so 10% for each one. So I'm going to take 68,000 times 0.80. That will only do 54.4 after the reduction, because of the extra restrictions I put in it. Well, that won't work, so let's move up to the next size. Okay. Now, my minimum value is 73,000, and my max is 140. Well, I have a 60,000 BTU appliance. Does that meet the minimum? Do I have enough heat with 60,000 BTUs? Nope, I don't. I can't do that. So I can't use 4-inch single wall connectors to do this because I can't produce enough heat. Can't produce enough heat. My 60,000 does not fall in between that. Can't get it hot enough. So nope, I can't save money by going to single wall metal connectors. The only way I can do this venting system, the way it's drawn, with all those elbows in it, is to do the whole thing in 4-inch double wall, because I can't do it in 3-inch because I had to take the reduction for the elbows. So I had to move up to the next one. After I took the reduction, I still had enough capacity to get 60,000 BTUs of it. Our answer over here is going to be 4-inch B-vent, okay, because of the reduction, and this is going to be 4-inch B-vent, okay. Everyone with me on that? You're going to see
Wait, I have a
diagram.
question.
Yep, go ahead.
Why did you do 0.80?
Okay, so if I have 100, okay, and we're dealing in percentages, so let's see if I can explain this in a way that makes sense, okay. I have 100%. For every extra elbow, I've got to take 10% out. So that means I've got 2 elbows, so I've got to take 20% out of my 100%. So that leaves me with 80. Okay, so the math that you're doing on it basically, 60,000, okay, times 0.80, because I lose 20%. Okay. I've lost 20%. 0.80 is the same thing as 80%. Okay, so I've lost 20%. So I times it by 0.80, and that tells me what my new capacity is. Does that help you understand?
Yeah.
Okay. So let's say I only had 1 extra elbow in it. Okay, the math would look like this. 60,000 times 0.9, because I lost 10% due to that 1 extra elbow. Okay, and if we go back to the vent sizing handbook that everybody read, back up here, they even give you an example of how to do it. Okay, tables should be reduced by 10%. So because 100%, I lost 10%, it's 0.90. If I lost 20%, it's 0.80. Okay. If I lost 30%, 0.70. Okay. So again, I can't emphasize enough to you guys, the answers are all in the book. Key thing to remember on test day, do you understand the rules? Do you know where to go find the rules? If you had to do this, you can do it as long as you follow the rules. And now we're going to go into 2 appliances. We just did a bunch of single appliances in different scenarios. Okay. Now we're going to go into 2 appliances. Aha, 2 appliances. Okay. Diagram number 10. So if you will all please get diagram number 10 in front of your face, we will go through it, because now we're dealing with 2 appliances. And things change when you do 2 appliances. Okay? We got to use a different table, and there's a little bit of a different process. Okay, everybody got diagram number 10 in front of them. All right, again, this is what you're going to see on test day, are diagrams like this. They're going to give you information. Total vent height is 15 feet. We have a fan-assisted 100,000 BTU furnace. Now we have a new thing in there called rise. When you start dealing with multiple appliances, lateral goes away and you start having a thing they call rise. And rise is the distance from here to there in a straight line, okay? The rise from here to there. Again, this is our main common vent. This is considered a connector, and this is considered a connector. And our rise is the distance on this one from here to there, and on the other one from here to about there, okay? Okay, now you've got more information they're asking. Water heater connector size and type, furnace connector size and type, common vent size, okay? So now we got to figure out what can we use on the water heater for the connector. So the connector is this portion of it here. What can we use on the furnace for the connector? That's this portion here, okay? And what size is our common vent? This is where we get into the scenario someone asked earlier about different sizes connecting into a main stack. This is where we're going to learn about that. Okay. So we're going to go back over to our venting size book, or the gamma tables. By the way, guys, the tables that are in the good practices book and the IFGC are exactly the same as these tables. So if you don't have this book with you, the tables in the good practices book and the tables in the IFGC are exactly the same tables. I'll get the tables over here pulled up so you can see. Okay, so here's the tables in the good practices. They're exactly the same. So you can use this book, the good practices, or the IFGC. The tables are the same. They work the same. You do the same thing. Now, we are not dealing with a single category 1 appliance anymore, so we can't use this chart. We've got to go find where we're dealing with multiple appliances. I can't use table 2 because it's still for single category 1 appliance. So, multiple appliance sizing tables. And oh my goodness, if you read the book, they explain how to do all this, okay? They even give you examples, okay? If I had read the book, I'd be highlighting this stuff, but whatever. I'm gonna skip right to the table and show you how to do it. Table 3, serving 2 or more category 1 appliances. We have the same scenario. Type B double wall main vent, which will always be a type B, and a choice of connectors. Type B double wall connectors, or we can go down and we have a choice to use single wall connectors. We're going to take this one here, number 10, and we're going to start answering these questions. So the first one is the water heater connector size and type. So our water heater is a natural draft appliance. It says NAD on it. This is important. You got to pay attention to this stuff on test day. Natural draft, 35,000 BTUs, 3-foot rise, 15-foot total vent height. All right, I'm going to go into my sizing handbook, serving 2 or more category 1 appliances. I'm just going to start with double wall and see if I can do the water heater in double wall and what size it might have to be. So same process. I come over to my height. My total vent height is 15 feet. My rise, okay, now we got a new term. We got a rise instead of lateral. When you're dealing with 2 appliances or more, they start taking into account the rise rather than the lateral. Okay. And in this particular case, I have a 3-foot rise. So I come down the rise column and my 15-foot height with a 3-foot rise. Okay. Now that I've got that, my water heater is a natural draft appliance. So I come back over here, and again, I've got 2 columns. I got my fan with a min and a max and a natural. So now that I've got my height and my rise for the water heater, I want to see, oops, there we go. My water heater's 35,000 BTUs. So I come over to the natural column. It's a natural draft water heater, and it tells me with a 15-foot total vent height and a rise on the water heater connector of 3 feet that I can have a maximum of 40,000 BTUs. So I could use 3-inch double wall to vent that water heater because it's only 35,000 BTUs, right? And my max is 40,000. So it will accommodate 35,000 BTUs, correct? Okay, everyone with me so far? So I'm going to go over here and my water heater connector size and type. Oops, get my typewriter. I have determined that I could do 3-inch B vent. Okay. Let's go over and see if we can do the water heater connector with single wall pipe now. Okay. So I've got to go down and find the table for single wall connector. Okay, here we go. 2 or more category 1 appliances, and I want to try to use single wall connectors for the water heater. Just do 1 appliance at a time. So again, same process. 15-foot height. Okay. 3-foot rise. And hey, I can switch that connector to single wall if I wanted and save some money, right? Because I only need to get 35,000 BTUs up it. Oops. And single wall will handle 39,000. So let's go back up here. 3-inch B vent. Or 3-inch single wall. Okay. Oops. So on test day, if they were to ask you the question, what is the minimum type connector you could use on the water heater? Well, on this one, you could use a minimum of 3-inch single wall. Okay. You can go either way. I can go single wall connector here and save myself some money. Okay. So I figured out that one. Now we do the same process for the furnace. I want to figure out on the furnace, what does my connector size and type have to be? Okay. So I've got, again, 15-foot height, and I've got a 2-foot rise on my furnace. So I go back into my sizing handbook. I go back up and I'm going to start with double wall. Okay. The reason I do that is double wall always, I mean, most of the time double wall always works, but double wall is expensive. So guys want to try to switch to single wall when they can to save money. And the charts will allow you, as long as you fall within the parameters. So now my furnace is a fan assisted furnace at 100,000 BTUs. So again, I come down my height column to 15 feet, but now my rise has changed to 2. Okay, so we move that arrow up there. Now we're dealing with a fan assisted appliance. I've got to fall within the min-max range. Okay, and it's 100,000 BTUs. So 3-inch doesn't work. Okay, Let's go over and look at 4-inch. Does a 4-inch connector work? No, because I'm over the max, right? Okay. Let's go over to a 5-inch. 100,000 BTUs fall between 49 and 153? It does, doesn't it? I've got my minimum amount of heat and my maximum. I'm not going over my maximum amount. My furnace, let's go back over here to this. Okay. Furnace connector size and type. Okay. 5-inch B vent. Okay. Will work. We know that. We just did it. Okay. But what about single wall? And we try to see if we can do it with single wall and save some money. So let's go down. So we go down to the chart for single wall. Okay, so now I'm in the 2 or more category 1 appliances, single wall connectors. Okay. Again, my height was 15 feet. We're working with the furnace now. The rise on the furnace was 2 feet. Okay. So now we got to come across and see. So on a fan assisted, because it's fan assisted furnace, 3-inch. Can't do it. Not recommended. Okay. Well, let's try 4-inch. Does 4-inch work? Nope. Okay, because we got a 100,000 BTU furnace and we have a minimum of 83 and a max of 94. Does 5-inch single wall work as the connector? It doesn't, because I gotta have a minimum of 121,000 BTUs of heat energy to use the single wall connector. But I only have how much? 100,000 BTUs. I cannot use a single wall connector on this furnace. Okay, everyone with me? Understand why? I don't have enough heat in the furnace if I put a single wall connector on it under these conditions to keep it hot enough. I've got to have, according to the gamma charts, a minimum of 121,000 BTUs, and I can't go over 150, and I've only got 100,000. So my only option for the furnace is B vent. I can't use any single wall in there. My water heater, I could use 3-inch B vent or single wall, either one, okay? But for the furnace, I can only do 5-inch B vent, because you saw when we tried to do it with single wall, we can't keep it hot enough, and down here we don't have enough capacity in the pipe. The pipe's not big enough. It won't move that amount of BTUs. So we've answered the first 2 questions. Now, you've all noticed these new charts have a common vent diameter, a new chart at the bottom. Aha! Here's the deal. Here's how this works, okay? I'm going to go ahead, because I want to save money, I'm going to vent the water heater in 3-inch single wall. I already know I can only do the furnace in 5-inch B vent. So to figure out the common vent size, I've got to come back over to the sizing handbook. And because I have a single wall connector in the system, my water heater is a single wall connector, I've got to be on the single wall chart, because there is a single wall connector in the system. And I come down to this new little chart at the bottom that wasn't on the other charts, called common vent diameter. And again, because I have a single wall connector in the system, because I decided to do my water heater with the single wall pipe because the chart said I could, I've got to be on the right chart, and I just simply come over to my vent height, and it was 15 feet. So I read down to the 15 feet, And let's see, are my appliances 2 fan-assisted appliances or one fan-assisted and 1 natural draft appliance? I've got a fan and a nat. Okay, this is what you got to make sure you're looking at. I could have everything fan-assisted, a combination of fan and natural, or everything natural draft. Because I decided that I'm going to do the water heater in single wall because the chart said I could, and I'm going to have no choice. The furnace has to be 5-inch B vent, the chart told us. Okay. I have a combination of fan and natural. Okay. So now I've got to come across and find the common vent diameter that will handle my total BTUs, and my total BTUs are 135,000, right? 100,000 BTU water heater, 100,000 BTU furnace, 35,000 BTU water heater. And so I come across, I have a combination of fan and natural draft. 4-inch won't work because I need to get 135,000 BTUs up it, and that will only give me 108. All right, well, let's go over to 5-inch. Hey, a 5-inch will let me do up to 159,000 BTUs. I need 135, so a 5-inch common vent would work, wouldn't it? Okay, so we go back, go back to our, and my common vent size is going to be 5-inch, always B vent. Okay. Everyone follow along with that? This is where they start getting complicated, when you start getting multiple appliances. Okay. Now, let's go back and take a look at this a different way. I'm going to go back up here and go, I hate single wall, or for whatever reason, I can't get single wall on there due to clearance issues or whatever. Okay. Well, we determined that 3-inch B vent would work also. So now I've got B vent and B vent. I go to size my common vent. I need to now go back up because everything in the system is B vent. Go back up to my, everything in the system is now B vent chart. Okay. So everything is B vent. So I've got down here where everything is B vent, the same thing, a common vent diameter. So I just go through the same motion. Come down to my 15-foot height. Okay. And we got to find a fan nat combination that will do 135. So I come across. 4-inch won't do it because it will only let me get away with 112. So I'm going to come over. 5-inch. So whether I'm using B vent or single wall, my common vent diameter is still 5-inch. You're going to see these diagrams, and I've given you, you've got plenty of them to practice with, where they're going to ask you pick the minimum type of material for this water heater. So we found that we could do it in single wall. So your answer would be 3-inch single wall. And we found that this one was only 5-inch. We could only do it in 5-inch B vent. The single wall chart wouldn't work for us. And then you're going to have to get the common vent size. So you need to remember when you're working on the multiple appliance tables, if all of your connectors are B vent, there's table 3. You work off of that table. If you're throwing single wall in as one of your connectors, then you need to go down to table 4 and work off of that table, because it can change your common vent just by having single wall connectors in it. Okay. Whew, that's a lot of stuff to remember, huh? The beauty is, guys, the answers are all in the book. Okay, and if you'll just take the time to read the book, highlight the important things that we've talked about, and go through those practices I've given you. I gave you 16 practices to go through. You'll get this, okay? It's just like anything else. If you don't do it, you can sit in a class and learn something new and leave the class and don't do anything you learned in the class, and 3 weeks later, you will have forgotten everything you learned in the class. That's just a fact of life, and it's how it is. So you've got to practice this stuff, or you won't get it. So that's why I gave you so many practices on this. As you're going through your practices, that's your homework, is to finish the rest of the practice diagrams. The answers are all in the books, guys, okay? I can't emphasize that enough. Read the books. The answers are there. Do the practices. If you have any problems at all, please don't hesitate to call or email me. I will work with you one-on-one on this. That being said, any questions before we end? That was a long haul today. Okay, we will do the 10th. So next Thursday, 8 o'clock, I'll send out the link. Your homework is to finish the rest of those venting practices I gave you. Again, if you're struggling, please reach out to me. I'll work with you one-on-one on this, because this is the most complicated part of the test. It really is.